Okay, I like to finish the last parts of chapter 6. Of the chapter 6, chapter 5, then you can finish, then I can finish the lecture of chapter 5, then you can do the assignments and do next week. Okay, I think some parts of our assignments, it's already, I think you can do it already. Then I like to mention the last parts of the overall F test. And in fact, these parts in our textbook, they introduce the two kind of F statistics, two kinds of F test, okay? Although in this homework, the partial, when we say the partial F test, it's really, it's not in this homework, but it will be in next homework. So I will do it, this time. Then you have to remember how to do, especially in computers. Okay, the explanation is already in the textbook, but there's no example. But actually, we do have that assignments next time. Okay, so I like to use this example to show the F test, both in overall test and partial test. Okay, first of all, I think I already done the overall test, which is on page 162 textbook. Okay, and in this, when we say overall F test, is want to test the whole models. Okay, the whole models. Therefore, in this example, we do have 3 independent variables, and we introduce all the t-tests for individual independent variable test. And the overall test is to test 3 of them at the same time. Okay, therefore, the null hypothesis, okay, will be 3 coefficients. Okay, so it will be beta 1 equal to beta 2 and beta 3 and equal to 0. Okay, an alternative hypothesis will be at least 1 beta j not equal to 0, and j is 1, 2, 3. Right? Okay, so this is the step 1. Step 1. Then step 2 will be alpha level. Okay, again, that's just using 5%. And step 3 is what kind of tools we want to do it. And that tool, we call it test statistic. Okay? And in this time, the test statistic is what we call the F test. Okay? The F test, which is not shown here, but you see this one. Did you see the information, this one? Okay, look at this one. This is what we call the F test. And we do see these 2 numbers, 3 and 29. Okay, this is the degrees of freedom from numerator and denominator. So actually, the F is using something divided by something. Okay, and those tables, I think I showed it last time, which is called ANOVA table. Okay, which didn't show in the EVUs. but we can see it from Excel. Okay, I think I did it last time. And from the ANOVA table, the F value is, in fact, is using some numbers in the numerator divided by some numbers in the denominator. With numerator and denominator, they do have degrees of freedom. And according to the ANOVA table, the degrees of freedom in the numerator will be put on the front. Okay, and the denominator will put on the letter. Okay, and this one, the degrees of freedom of numerator is set, the number is the same as the number of independent variables. Okay, so we do have 3 independent variables. Therefore, this is 3. All right, and what is the degrees of freedom from the new denominator? Is using total sample size minus number of independent variable and also minus the constant. And this will be the same as the individual t statistic. Remember that? When we do the t-test for individual independent variables, the degrees of freedom we are searching for is, from the table, is 29 too, right? So the degrees of freedom, there's 2 degrees of freedom from F statistics. One is in the front, is the same as the number of independent variables. And the latter one is the same as the T statistic for individual independent variables. Okay, so the F test shows that 15.65 something. Okay, so I just write it down, 15.65. And this is the F distribution, okay? And actually the p-value shows here. Okay, so everything you can read it from the table. The information is all from the output. Okay, the p-value is here. So this is something very small, right? This is something very small. So it's close to 0.001. Okay, all right. And in this case, step 4, again, is the decision rule. Okay, then we're using F distribution. If we check it with the table, the F distribution is something like this. This is skewed to the right, usually, okay? So this one will be F329. And if we're using alpha 5%, would you check it again from the table, which is at the back of our textbook? Okay, remember in our table, in that table, you have to locate it one with alpha is 5% instead of 1%. There's a 2 F tables. One is 1%, the other one is 5%. Now we are using alpha is 5%, so you have to find the one with 5%. Okay, then check with the degrees of freedom with 3 in the numerator and 29 in the denominator. So what is it? This is 5%. What's the number? 2.992. Okay? So this is what we call critical value, right? Right? This is critical value. So again, we do have 2 approaches. One is critical value approach. The other one is p-value approach. So according to critical value approach, the F statistic, the number is 15.65. So which is far beyond the 2.92. So somewhere here, okay, is 15.65. No wonder the p-value is actual tail area of the test statistic. Okay? So p-value is such small, since we know that from the diagram, we know that the area, the tail area of 15.65 must be very, very small. Okay? So according to the critical value approach, 15.65 is greater than 2.92. And if alpha level 0.00001, this is really small, right? It's much smaller than 0.05. Okay? So with this two, we all end up with the conclusion is reject the null hypothesis. What do we mean reject null hypothesis? We reject this one, right? And this, what does this mean? This means the model is useless. Okay? This means the model is useless because when beta 1, beta 2, and beta 3 all equal to 0 means what? None of them can explain the variation of the y. So the model is useless. And this one, say, at least the 1 beta not equal to 0, the model is useful. Okay? So this is model is not useful. This is model is useful. So this is what we call overall test. Overall test. Okay? Then what I'm going to introduce, one is in our textbook, which is on page 161. Okay, this is what we call partial F-test. Partial F-test. What do we mean by partial F-test? Okay, I think if you wanted to write down something, as a note, okay, you can put it on the page 161, which when you read it by yourself, you may not able to see the key points at the same time. Okay, and I think we do have some examples in our textbook on page 164, which shows the partial F-test. Okay, all right. If I wanted to check, okay, look at our independent variables. The n is related to competitors, right? And the p and I, p is related to the population, resided in the area of the restaurant, and income is related to those families earned annual income. Okay, so maybe I like to see, since this population and income is a little bit related, not exactly related, but somewhat in the same dimension of the information from the same dimension. So if okay, in our textbook, in some of the situations, if I have some independent variables which shows the seasonal effect, we all know that some goods really has seasonal effect, right? For example, if you for those refrigerator, okay, is more maybe I'm not sure. Maybe it's more popular in the summer season, but not in the winter season. Okay, so I can put like spring, summer, and fall as a group, then winter season as a group. Okay, so if I really want to check whether the first three, except the winter season, all of them do have important factors to the price of the refrigerator, suppose. Okay, so this is what we call partial F-test. So I think it's important for all of you to learn the partial F-test is someday in your thesis. Okay, maybe you are doing some kind of research, and the independent variable you located from the literature have some, dimensions, maybe the 3 dimensions. And from each of the dimension, you do find several important factors. Okay, so you would end up with like something 5 or 6 independent variables, but separated in 3 dimensions. And if you want to check either one of the dimension really and how important that each dimension to affect the y variables, then you can use the partial F-test using those variables as a dimension to check, the importance to the y variables.
So the t statistics and the p-value test with the for the t test with the t critical value and the t ratio and the p-value, so the p-value and the significance level. So that is to test individual coefficients, right?
Right, individual, only individual. Therefore, when we explain the meaning of the coefficient of individual independent variables, we need to add on what kind of terms? Holding other variables as a constant, right? Right? When we do interpret the meaning of the coefficient of individual independent variables, especially in multi-regressions, we should say that holding other variables as a constant, then what happened to these independent variables. Okay, so in other words, for all the t-test is for individual x variables holding other variables as a constant. Okay? So if we do the partial F-test, that means if I have 5 and I want to make it the first 3 as a 1 dimension, so I say I'm doing a partial F-test, that means that holding other variables as a constant in the models. What happened to the first 3 together to the variable of the y in the model. Okay? All right, you see the difference? Okay, so now I like to show that whether I like put this one n as competitors as a 1 dimension, and if I put p and I as the other dimension. So I wanted to check whether P and I together has importance to the models. Okay, so in other case, what is my null hypothesis? Just only 2. I don't have beta 1 anymore because I wanted to check P and I together. So therefore, it's beta 2 equal to 0 and beta 3 equal to 0. Okay? Then at least 1. Now I don't have 1 anymore. And in this case, step 2, I'm using alpha 5% and also the test statistic. But this test, the statistic, if we want to calculate it, is from the formulas from equation 5.10. Okay? But I'm not going to show this way. I'm going to show how the e-views, you can use the e-views and do this partial F-test. Okay? So you need to see. Let me do this way. Okay? This is from e-views. I have to, let me show where's the data? Where's my data? No. Maybe, oh, here. Do I have this one here already? Chapter 3, right? And e-views. Okay, this is UDI 3. Okay, let me do this one. All right. See clearly, okay? If you can, write it down the step, what I did from the e-views, okay? You know, first of all, I need to show the output. Open as an equation, okay? And this procedure is exactly as the output I have to show. I have to run every time for the whole models, right? Okay. Then, with the whole model, okay, with the whole model here, I need to, did you see the function here, view? Do you see this one? View. You all see this one? Function, view. Okay, maybe you can do at the same time if you have, I think you all have data, right? Do it as what I did. Follow as what I did. Then you can remember how did I show it. Okay, and from the e-views, the constant is at the bottom. So it started with NPI, then constant. Therefore, the location of the coefficient here, okay, will be the first one is N, the second one is PI, then C. Okay, so let me show this. Did you see the view? Hit on the view. There are several functions. Okay, did you see the one from the last 3? This one, coefficient diagnostic. Did you see that? Coefficient diagnostic. So I hit this one. Then there are several sub-functions. And choose the one with coefficient restrictions. Did you see that? Wall test, coefficient restrictions. You see that? Okay, hit this one. Okay, then coefficient restrictions separated by comma. What does that mean? Now I wanted to check P and I. In this parts, the example shows here. Okay, so although I write it down, it's beta 3 equal to beta 3, beta 2 equal to beta 3, which is the same as, I want to do it the P and I, so it's C2 equal to 0, separate, and C3 equal to 0. You understand what I'm saying here? So I have to say C Okay, I write C2 equal to 0, C3 equal to 0. Okay, this is follow the instruction of their examples. So I may not write it as C2 equal to C3 equal to 0. No. I have to separate it, and separate it by comma. So this expression is the same as what I want to do is this at the same time. All right? You understand what I'm saying here? Are you lost? Huh? You all with me? You all with me?
Sorry, I missed. Where did you click to the wall?
Views, view.
View. Thank you.
Views. You all with me? All right. If you're all with me, then I hit OK. This is the output. And what did you see? You need to see the statistic, and which is from F statistic. You know, you don't have to read the chi-square or something. You know, that's same test but with different formulas. Okay, the one here is the one from our textbook, 3.10, 5.10. Okay, so what's the F statistic here? 22.68. So in other words, now if I'm doing this 2 coefficient only, then what's the F values? Is 22.68. And what's the degrees of freedom? Now we are checking only 2 independent variables, right? Okay, so degrees of freedom and 229. Did you see that? F is 229, okay? And so can you check it for me? If I have the F values with also 5% and the degrees of freedom is 229, what's the critical value from table? What? 3.32. Okay, so look at this one. As long as the degrees of freedom change, the critical value change too. Okay? All right. So, using this one, I'm going to write it down. This is 22.68 is greater than 3.32. Again, this is far beyond the 3.32, which falls on the rejection region, right? Okay? And what's the p-values here? Did you see the probabilities? It's real small. Did you see the column of probability, which is the p-value? So again, this is real small. So I'm going to say that it's really close to 0 because it's really small, right? So of course, it will be smaller than 5%. So reject the null hypothesis, which means as a group of P and I, which both of them are very important to the models. Okay? So this one, you should get it from the eViews. You are not able to, this is from the other functions, from the eViews. You are not get it from original output from the equations, because this is just only the partial test. Okay? Nowadays, from chapter 6 and chapter 7, we will use this function view very often. Look at the view here. There are so many functions here. It's related to something we have to learn, including this semester. Okay, we're going to talk about coefficient diagnostic, residual diagnostic, several of them. So you should be familiar with all those functions. Okay, this is what we call the partial F-test. Okay, and I think I finished everything. Okay, there's one small part which I need to also explain it, which is 5.4. Okay. Any questions for the overall F-test and the partial F-test? Is that clear for all of you?
Yeah, I didn't understand why there is the normal version of the F test. We just use the OLS result table. So we have already the F value, and we just have to search for look for the FC, and then there is the wall test, and then we get different.
Well, this one is partial F-test, right? The original output is show all the information about the whole models. Okay, then I need to know some partial parts information from the models. So therefore, they set up several additional functions which help us to find all the information we needed. In a computer output, have to meet all the requirements or all the needs for the researchers, right? Okay.
That will be like a personalized test with what you want to put in the wall test.
I would say the personal test, but which is already, established or is already find out from the theory. All this is from theory.
Yeah, sure. Cool.
Yeah. They already have that theory set up. Therefore, the programmers using that theory and writing the programmer, then put it as additional functions which is convenient for the users.
So for the overall fit test, we can with the null hypothesis being QF1, QF2, and QF3 equals 0.
Mm-hmm.
So that's
This is the whole model.
Standard.
Yeah, standard.
If you want to try another null hypothesis, you have to try to use the wall test.
Yeah, partial. Yeah, that's right. Okay. Then, with all this, I just showed that we have, from the view functions, we have many sub-functions, okay? And so what does that mean? You have a lot to learn, not just the whole output. There are so many, purpose during the research, right? There's so many functions. Although, in master's level, we will teach you all which is important for all of you. But if you are in PhD program, then there's more methods or more functions you have to learn. Okay, so today I'm just going to show that the first one you have to see from the view functions. Okay, we will see this often, more and more in the future, especially if we start from chapter 6. So that's why I'm saying that chapter 5 is the foundation for the rest of the chapters. Without knowing this, you are not able to go on further. Yes?
Is there any possibility that the partial ones do not support the full test?
Oh, sure. Of course. But in this one, is support. Yes, support. Okay? So like what I say, that especially on your thesis, okay, maybe you like to do some kind of research, which is your Y variables. Then from the literature review, then there's 3 dimensions, factors to affect the Y variables. Therefore, in each dimension, you may find 1, 2, 3, those important factors, and put them together as a model to explain the Y. But you want not only the whole models you also wanted to know that individual dimension, including several, small, not all the independent variables, just some parts from this dimension, like 3 variables together, and see overall, this dimension, how does this dimension affect the model? Or how does factors to affect the y variables? Okay? All right, I think this is important. Yes.
So the probability is using for the p-value of G5.
Yes, from the output here.
Okay, so for the result, the smaller is better, or
Yes, for p-values, probabilities, always compare with the alpha level. Okay, what do we mean the alpha level? Alpha level is the type 1 error. And alpha level is what we call allowable type 1 error. And we know that type 1 error is very important. It's more serious than type 2 error. I think we explained it at the beginning. Okay? So since alpha is the allowable type 1 error, and the p-value probability is the observed type 1 error from the data. Okay, therefore, the smaller the p-value means that, if I have the alpha 5%, it means the allowable mistake is 5%. But with this data, I find out from our data, as I have only very, very small probabilities, like this one, is even close to 0 to make the type 1 error, which is good or not? Which is good or not? The good or not is in terms of the null hypothesis. If you reject the null hypothesis, means you support the research hypothesis. And the purpose to do the hypothesis testing is to support alternative hypothesis, right? So if you have small p, means your type 1 error is such small that you can, really boldly to reject the null hypothesis without any worry or something. Okay? So p-value is smaller than alpha, then we will reject the null hypothesis. And for critical value approach, again, this critical value separate the rejection region and non-rejection region. So this is also a criteria. And the critical value is really from the level of alpha significance, right? So this number is from alpha level. So therefore, either critical value approach or p-value approach, they do really tell the same story, but one is from probability side, the other one is from numbers size. Okay? All right. So I like to mention the homework. Okay, here. Let's turn to the. Any other questions? Any other questions? Okay, if you don't have any questions, let's go to our assignments due next week. Okay, and which is lab number 3 on page 173. Okay, and this is talking about the life expectancy. Okay, so how many variables do we have? Have you read the examples? The first one is y variable. First one, okay? The first life expect is y variable. Then the rest of the 7 are independent variables. Okay? And look at those steps. Those steps is really follow the step we learned from chapter 3 that based on the 6 steps, do the regression analysis, right? Okay, and so the step 2 is hypothesize the sign of coefficients. Okay, let us decide the signs together right now. Okay, all right. The first one is median household income. How does that affect to the life expectation? How do you think? You can have positive sign, a negative sign, or both directions, right? How do you think? How does the income affect the life expectancy? Means that maybe the wealthier, the longer life. Is that what you mean? All agree with that? Huh? Do you all agree with that? Wealthier and longer life is for sure? Huh? You want to do the positive sign. Okay, then let's make it positive sign, okay? I think I like to set up, as a same for everybody. Okay, when we do this one, since we need to do, one-sided test and both sides, two-sided test, so we need to uniform our expectation about the signs. Okay, you all agree with that? Wanted to do a positive sign or two-sided? Huh? I think according to the literature, maybe it's not that clear. Okay? So why don't we do it both-sided, okay? All right? Feel comfortable with that? So both-sided, okay? The second one, uninsured, means that whether do you have the insurance or not. How do you think? How do you think about this one? Maybe positive, right? Maybe? Huh? Uninsured. Oh, okay, I'm sure. But the person with uninsured then should be negative, right? Okay, should put it negative. Then smoke. Oh, everybody agree with that, right? But there's still have more people smoking, right? So this is negative, okay? Then obesity, negative, okay? Then teen birth. Teen birth means number of births to teenage mother, negative. Gun law, this means whether this state has the firearm law to protecting children. Positive? Or, I don't know. Maybe it's positive, right? If you have this kind of regulation, and maybe positive, right? Okay. Then metropolitan means the percentage of population in state that live in metropolitan states. This really two ways, right? Okay, so let's make it two ways. So, first of all is median income. You wanted to make it positive? I think there's more people think it's positive, right? So why don't we make it positive, okay? Positive, negative, 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 and positive, and two ways. There's only two ways. It's metropolitan, okay? All right. So this uniform, the directions from each variables, okay? So we have already done the step 2. Okay, then I'll do the rest of them, okay? And I wanted to make sure, okay, step 5 and step 6, okay, although they put it as one is using t-test, the other one is using p-value, and I wanted to, like all of you, to do the both ways. Huh? What do we mean by two ways? Critical value approach and also p-value approach. And if you had two-sided, then you have to use 3 ways. Confidence interval approach. I did it last week for two-sided. Okay? Then step 7 is only overall F-test. You don't have to do the partial. Not in this example. Okay? But will be next assignments. Then step 8, draw conclusions, and then say something about what they are asking for. So is that clear?
Can I ask you, so for the step 5 and 6, you want us to do only one-sided? Or you want us also to do two-sided?
Okay, for step 5, talking about smoke, teen birth, medical median income, and uninsured. For this is 4 variables. Okay, do critical value approach for 2.
Okay. For 5 and 6, you want us to do both as well.
Right, right, and which variables is two-sided? Metro, METRO, right? You have to add one more approach, which is significance confidence level, confidence interval approach. Okay, which is on step 6. Metro is on step 6, right? And both are using 5% level. Okay, is that clear? Okay, this is due next week. Okay, so the following 2 classes, I'll ask all of you to do the presentation for the 3rd assignments. Okay, let's take a break.